So today we're going to talk about the inverse of linear functions. So to find the inverse of a linear function, basically you switch the input and the output. So if we have the input as A and the output is B, the inverse, the input is B, the output is A. Alright, so you'll notice with the coordinates, basically your X and Y values will reverse. Right? The domain becomes the range, and the range becomes a domain. So for this example, the inverse, the -10, 4, -19, 7, 17, -5, and 11, -3 would be the inverse. We switch the domain and the range, or the X and the Y values. The signs stay the same, everything else stays the same. For B, if we're going to switch the X and the Y values and inverse, the new coordinates would be -13, -4, -8.5, -1, 0.55, and 6.59. So we're switching again the X and the Y. For graphing an inverse, we can see that the original graph is here. If we pick some points on the original graph, it's the easiest way to kind of do the inverse and think about the coordinates of those points. The original coordinates are -6, +8. We've got 0, +6, and we've got 6, +4. If we inverse those, the new coordinates would be 8, -6, 6, 0, and 4, 6. So I'm going to plot those points: 8, -6, 6, 0, and 4, +6. And we're going to make that line, and we'll make it in a different color so we can see the difference. And those are the inverse. When you inverse a function, a linear function, you should always find that the graph is symmetrical about the graph y equals x. So you can see the mirror image across the line, y equals x. So if you draw that dashed line in, you should see that it's a mirror image. That's a way to check your inverses. So that's how you graph the inverse of a function. You're going to find points on the original graph, inverse them, and then replot the graphs.